Today we're taking a look at these little battery testers. These happen to be branded ANEG, but sometimes you get them completely unbranded. I don't know if they came up with a design and then it got ripped off, or if an OEM makes these. No idea. These things are pretty cool because they let you test all of your individual cells that you have laying around the house, and you're not sure if they're good or not. Positive always goes towards the clamp side here, the sort of red side. And then you just slide this in here and it gives you a quick indication. This one is 1.24 volts. Of course, this cell started at 1.5. And then you look in the back and that tells us this is a low power cell. Below 1.15 you replace, but this one's low power. So it does all sorts of cells, right? It goes pretty big, up to 4.8 volts. So I think you can do an 18650. We'll check that as well. And it also does 9-volt batteries. For the 9 volts, though, it's actually pretty interesting. It has little ridges here, so you can't put the wrong polarity on it, which is pretty nice. But you just hold that up like that. Oh, hold it tight. Pretty much 9 volts. And for a 9-volt battery, that is as good. So why can't you just use a regular multimeter? Well, a cell will have a pretty high float voltage, and we'll check that in a moment. So the voltage will be pretty high, but this thing should put a small load on it, which we will check, and that tells you the voltage under load. So there must be a standard, but I mean, we'll take a look at what this thing actually does. So that's pretty good. So this one here is the same concept, but instead of a moving jaw, and some of these jaws are sprung, this one is not. Instead of a moving jaw, it has this weird sort of puzzle piece feel that you just go like that and you touch the other contact. So it's quite obvious that the whole contact here just goes across, and you just need to, touch one end to the other. Also has the 9-volt section. However, you have to be a little bit more cautious of how you connect it because it doesn't have little ridges protecting that. And apparently this can do little coin cell batteries too. So we need to see about that. So I think the first step is we're going to pull these apart and see what they look like on the inside. Seems to be a Phillips 1 on the back here. So I'm going to use my nice Weehaw screwdriver to try to get into there. There we go. See, it's pretty deep. So there's one screw. And there's the other. And now there's moving parts, so everything is going to go flying for sure. Okay, so very simply here, we've got a contact on the red portion of this, the little trigger. And the red wire goes to here on this circuit board. And we've got another red wire going to the contact here. That's the positive contact on the 9-volt. And then this negative contact here actually folds around and is a negative for the 9-volt as well. See if the camera can keep focusing. And that goes to that little spot there. I'm going to remove this circuit board and we'll take a little bit of a closer look to see what's happening on the board. But I don't expect there's going to be too much magic here. Likely is going to be a driver for the LCD or the segment displays. And then probably going to be a voltage reg for that, and then there's probably going to be a transistor and a diode to feed that switches in a resistor, a different resistor for this one as this one, and that'll be it. I'm pretty sure. Ooh, a zebra stripe. So hopefully that zebra strip goes back together well, or else this thing isn't going to work. Let me zoom you in. So this is where the positive contact of the 9-volt battery goes, and here is the common ground. And as the voltage comes in, we go through a diode. So this is your reverse polarity protection. There is a 10 ohm resistor, which I assume is the load that it puts on the 9-volt battery. And then here you've got a 3-volt regulator, very likely to power this chip, which deals with the LCD. Then you've got a 10K resistor here and a 90K resistor. And I'm not quite sure what those are for, considering that if the positive path goes through here, a 10 ohm resistor and then 3-volt regulator here. And then, yeah, I'm not sure what this path is for because this is still positive here. That might be for the voltage sensing because it is going over to the chip here, right there. So this IC is completely nameless. And then if we go over to where the positive is for the 1.5 volt side of it, it's actually pretty interesting because here we have a 3K resistor right about here. This is the input path here. And then we've got a device I haven't looked up yet. I'll put it on the screen if I looked it up. And we've got an inductor. And then we have 2 caps and we have a diode. So that to me looks like either a buck or a boost, probably a boost converter. So this might control the switching through the diode here. And then we've got a 10K resistor, R11, a little capacitor, and then the chip. So that is it. I almost feel like the load on the 1.5 volt cell is going to be just this, this boost converter, because I don't think a 3K ohm resistor would be enough to load it up, but we're going to check it. We're going to put it through a current draw test on a multimeter. Let's take apart the other one now. Let's see how easy this one is to take apart. I'm assuming just as easy. Oh, a little bit harder. It's got 3 screws. Fancy, fancy. Ooh, and they're black too. They're not the silver ones, so they undergone a second treatment process. Looks like the middle screw is a bit smaller. Yeah. Looks like just the top screw is a bit bigger. The other 2 are smaller. See if this will go springing all over. Nope, not too bad. Again, tiny little PCB on this one. Although the PCB looks a little bit more complicated. And it looks like we have 2 separate terminals for ground. So this time the negative for the 9 volt and the negative for the other cells are different than the one. They're not the combined negative. And then, of course, you've got the 2 positives. So we've got 4 contacts here. 1, 2, 3. And this big one, number 4. Pretty neat how they did that. On the inside, we've got the same sort of arrangement where it's just resting a PCB on a zebra stripe. There we go. Single-sided board. Let's go take a look underneath the microscope. Well, we have the same kind of thing here. So we've got an inductor. This, I looked it up. It looks like it's a DC to DC converter controller, diode, and then another little diode here and a 100 ohm resistor. I wonder if that's the load resistor. Not sure. Then if we go down this way, we've got that same 3-volt regulator. We've got some 100K ohm resistors, a 5.1K, a little capacitor, unnamed chip. Over here, some of the worst soldering. I think you guys missed this. And then here, it's interesting because it says that this looks like the positive 1.5 volt connection, but it's definitely not. It definitely goes to the connector on the 9 volt side. So that's pretty interesting. And then this one here has both the grounds. So yeah, kind of the same thing as the other one. And this is all you get. Very cut down. Let's put this one back together too. All right, just a little quick proof that these still work now once I reassembled them. So here we go. It says 9.15 volts, and this one here, 9.02. A little bit of a difference between the two. And this part still works. 1.25 volts and 1.28. This one actually shows a little bit higher than this. So what I will do now is I'll bring up the venerable UT8805E up on your screen, and I'm going to probe to see how much current we're pulling through these two devices. So I'm going to put my, actually I'll put the negative lead up in here, and then positive on the top of the cell. And I'm just going to hook it up like this. We should get a reading there. Yep, here we go. And we are pulling just about 5 milliamps out of this 1.5 volt cell in order to test its voltage under load. And we can do a similar thing. Now the grounds should be connected. They do solder to the same spot. So I'm going to just jam my ground into here. Like so. And then I'm going to grab my positive onto the positive terminal here. Can be a little hard to reach. And that should be touching. And then here we go. So on the 9 volt side, I do have my leads backwards, but that's okay. 1.5 milliamps for the 9 volt. So that is for the BT189, the fancier one. Let's do the same thing here on the BT168 PRO. And I'm just going to see if I can get the positive on here. Now, again, the negative is the same, but this one, I can't jam my probe in. This one might be a little bit more fuss. Let's see if I can grab that. Not exactly ideal. Let's try with the 1.5 volt cell. So we're going to pop this in here and pop this in here. This one has the polarity protection, so it's a little bit harder to get it set up. Well, there we go. We're pulling 6, almost 7 milliamps of current for the 1.5 volt. This 9 volt is not easy to do. And 2 milliamps on the 9 volt battery side of this one. So this one does seem to pull more current, and thus will give you a little bit less conservative estimate of the remaining capacity than this one here. I mean, both of them are good, both of them are valid, but it does seem like this one will give you a little bit more realistic reading of how long your cells will last. But then again, that all depends, because it could be that these cells are in a TV remote, for example. And in a TV remote, it does almost nothing for its entire life. So, maybe this will be a better indicator for that. But something like a multimeter or, a child's toy that makes a lot of noise, this one here will give you a better indication because the current is a little higher. Got myself set up now to check the accuracy of the reading here. So let me put a cell across this. There we go. So this is showing 1.29 volts, but the UT8805E is showing 1.246 volts DC. Interesting, there's a difference there. I don't know if I'll be able to check it on the other one, though. This one is a little bit harder to manage, but let's see if I can do it. If I put my positive probe here, so if I can jam that in there. This might be too much of a faff to do without disassembling the tool again. Okay, so I don't know if you can see that, but it says 1.24 volts, and I'm reading 1.235. So I would say that this one here, actually, the cheaper one, is a little bit more accurate. That's really interesting. Let's see if these things will work with 18650s. Now, I do see that this will work with a 14500, with a 10440, and with a 16340, but I don't have any of those because the 18650 is the most common cell. So let's try on this one. This one definitely works, 4.18 volts, so this is pretty much full charge. Does it work with this one, though? No. There's no way to contort a cell to get into this. So although this does do up to 4.8 volts, you're not going to be able to use it with 18650s, which is a bit of a problem for me. So what about testing coin cells, like in your car's key fob or in your vernier caliper? Well, I think we can do it. So positive is the flat side usually, and the little button is the negative. So let's put it in here. Yeah, 1.52. This one works. And let's see if it works in this one. I don't know if you can close it enough. Oh, got to really be on that contact. Oh, whoops. It's backwards on this one. I forgot. There we go. 1.47. So that works. What about these guys? The CR 2034, I think. CR 2032. Let's see. Well, this one doesn't seem to be working. But is that a problem because it's dead or because it's not able to do it? I think they're just dead. Yeah, these are not working at all. I actually probably have to go get one that's known good to see if these guys will actually work. I went through my horde of coin cells and none of these are good. So I actually had to go steal one out of my key fob just to make sure that I had a good one to test. And here we go. So positive, negative. This one works, 2.93 volts. And then let's see if this one works. Yes, it does, 2.91. So it does work for coin cells as well. So in the end then, which one would I recommend? Well, I think this one is actually the better device because it just seems to be able to deal with more stuff. I'll put a link in the description to both of these things, but I mean, they do have their pros and cons. This one is quite a bit smaller, and this one is a little bit more finicky to use with the slider. But yeah, I think I would recommend this one for people that that know what they're doing with their cells. And You know, if you need something for your mom to check the batteries in her remote every once in a while, maybe this one is the one for you. Thanks for watching. Do I have to adjust the focus on this too? I definitely do. Figure video. It should focus, right? I don't want to have to focus this every time.